Hello and welcome to the Visi 2020 review. This is Jared, and we're going to go over all the new features in the CAD portion of the Visi 2020 software. So to start, we're going to start off with the prerequisites for the installation. This would be all the Pro versions for Windows 7, Windows 8.1, and Windows 10. One recommendation we do make is we would recommend upgrading to Windows 10 from Windows 7, as the Microsoft support is going to end as of January 2020. Note that in Visi 2020, you cannot, once a file is saved, you cannot open up a 2020 file in previous versions. You can open up previous version files in 2020, but it can't go the other way around. So with the installation includes the launcher. So the Visi launcher is the only way you can access the CLS license manager. This is where you would access it from. And then you would not be able to access this from the system tray anymore. So there is no more system tray. It's all through the Visi launcher. From here, we can also access the migration tool. This will be what is used to transfer your settings from one version to another. On the USBs you guys received, there's a video that shows step-by-step of how the installation would work. So we're going to go over some of the new translators in this version as well. So some of the new translators include supported versions for 2019 files, DWG DXF 2019 support, JT Open has been upgraded to version 10.2.1. Parasolid versions are now up to version 31. Solid Edge and SolidWorks are now supported for 2019 files. So here's a list of the newest translators. The ones highlighted in green are included in 2019 R1 and 2020 releases. So a new feature as well within 2020 is the Register Interface File Extension button inside of System, System Options, and the File and Folder Options. So this option is allowing you to register Visi 2020 as your default Visi structure. So basically what would happen in previous versions is you would open up a step file, and when you double clicked on it, it would open up in a previous version. What this Register Interface button does is it points everything to 2020, so that way you don't have to go into the registry and reset everything. So now we're going to go into the modeling commands. So within the automatic work plane orientation, they now have work plane by 3 points. You can draw axes on pipe surfacing now, and you have faster point editing for point sets. So we'll just show a video real quick of this. So under the work plane by 3 points, we go to create work plane. This is in the automatic work plane orientation. So you find your origin point first. You click and confirm. Then you use the Alt key to slide your X axis or whatever axis you're trying to point. And then you would choose a different axis to make your work plane by 3 points. So we use the Alt key once again, picking the arrow. And you can see, you could snap this to a different point. So as you can see, we snapped our X point and our Y point, thus making a work plane by 3 points. You can use the F2 button and it should automatically orientate to that specific view. So as you can see, that would be work plane by 3 points using the automatic work plane orientation. So next, we have drawing an axis on pipe surfacing. So if you're looking at trying to get the center axis point or the wireframe, you now have the ability to do that with pipe surfacing, whereas previous it was just cylinders. So as you can see, I'm picking out my pipe surfacing, and it very easily finds the center point. With this, I can draw points at each intersection area and draw circles at each intersection area as well. So lastly, once I'm in here, I can go to my surface analyzer, and as you can see, when I scan a face, it's going to scan to the center axis lines where it's drawing those lines at with draw axis. You can see the orientation is based on the faces you picked. So next, we're going to go into the faster editing for point cloud data. So we scan this data in, we can go into set up points and delete a point. You pick the point set, and basically what's going to happen is there's a lot more improved speed. So when you're trying to delete or scan out any points, or use a polyline to delete these points out, it clears them out, and it's going to clear them out in a much faster speed. So next we're going to go over region creation. This was introduced in 2019 R1, and a lot of questions that we've had were involving this. Why is there a yellow highlighted area around my work plane? It's because of the region creation. This is a combined wireframe and edge environment selection. It can be used for extrude elements and swing elements. So basically what it's going to do from a closed area with wireframe or edges, or the combination of the two, it will basically allow you to extrude elements and swing elements. This is only active on the current work plane. So we're going to show just a quick example of this. So under System, Settings, there's a checkbox for region creation. When it's checked, you'll see that highlighted yellow area. So if I use the rotation area for my work plane from YZ front to XY top, you can see the faces it's going to allow you to select. Each face would represent a different area that I could extrude a solid from. I could swing a solid from. So if we go to the YZ and go to extrude elements or swing elements, either one, and I just pick a face or faces that I want to swing. So I select the faces that I want to swing it around, choosing the application point. Previous versions I would have to use a profile to do this. Choose the axis. You can see how I'm swinging this part around. I can choose to unite everything together, making it all one solid, and confirm. So this is good for accessing modeling commands, creating something from a solid. It makes it quicker. So now as you can see, if we rotate to the XY top, you can see how that highlight's going to change. And now we can choose faces from this current work plane area. So if we choose extrude, I can choose a face or the faces based on those closed areas. I create this into a pocket or a boss. So in this case, I'm going to create this into a pocket, subtract it out. I can choose the distance I want to keep. When I update my view, the reason why it still shows as a region area is because there's wireframe lines around it. So if I went to transform my work plane, we're going to have a new region area, and that would be based on the bottom. So when I confirm my work plane down at the bottom, it's going to update, and now everything on that specific plane will be closed. So for example, I extrude these out. This is wireframe combined with edges. You can see how that's a closed area. I can extrude that now. I can add fillets. It's going to update that region area. The same thing on the other side. And I could draw some more boundaries around that as well and make that a closed-in area as well. So I just use sketch line here. And that's going to make that a closed area as well. So each one of those closed areas are going to be a separate face. So all I have to do is pick 3 faces, extrude those, whether I want to extrude a positive or a negative. In this case, I'm going to choose a positive, and I'm going to choose to unite that together with the other solid body. So that will join those bodies together. So even if it wasn't joined together, let's say I take another sketch line, I draw in between those. As long as it's an enclosed area, whether it's enclosed by edges or by wireframe, it will make that a closed area as well. So next, I'm going to take this wireframe line I drew out along those edges. I'm going to offset that into the part. So you can see how this is all one face right now. If I go to offset elements, picking that area, you can see how if we go to whether it's in both directions or reverse direction, you'll see that that is actually going to turn this area into separate faces. So it's separated out by the wireframe. So I pick somewhere where I want to go, choose the extrude elements command, choose to make this a pocket or a boss. In this case, we'll make it a pocket. And because we don't have wireframe that's wrapping around, you can see how that region's going to update and remove that area. So the next thing we're going to go over, and this is for those that don't have a progress license, we now have the ability to use the nesting parts within an analysis license. So basically, if you're trying to nest a certain group of parts of the same height, whether it's a solid or a surface, you can nest those onto a sheet. Basically previewing what's the XY values, what is your border gaps, what's the distance between parts, so you can preview what they're going to look like in a sheet. So no longer do you need a progress license to do this. This is also based in the analysis pull down. So from here, we're going to go into the 2D drawing commands. So this next one is segment arc. So basically you're using sketch line. You can use the Alt key to toggle between segments and arcs. You can delete multiple points from a point set, and you have the ability to undo a merge. Under the polygonize command, you now have the ability to preview a segment and arc, so it's going to tell you how many segments, how many arcs it's going to create. And you have the ability to copy and paste locked layers. Also with this to mention, we also have the ability to create to use save part as on a locked layer as well. So I'll just go over the segment or the segments and arcs or sketch line. So I use sketch by a chain. So as you can see, when I toggle the Alt key, you can see how it's going to turn it into a segment or an arc based on the toggle of the Alt key. From here, we're going to go into the polygonize command. So under wireframe, points, polygonize, we basically select all of those points. And then from here, I choose my starting point, and we could choose what are we going to do between each one of those points. We select segments and arcs. You'll see it's going to preview how many segments, how many arcs they're going to be created in between those areas. I can choose to give these different colors between them. I can choose to maintain a tangency. I can choose to retain original geometry, and so on. So you can see based on whatever options I check and uncheck, you can see how many segments, how many arcs it's going to create. Choose a different color. If I uncheck that, you can see how it's all based on one color. If I check that, it's going to be based on multiple colors. From here, if I merge a file in, basically what's going to happen is in previous versions, it would not allow me to undo that merge. So if I dragged and dropped a file in, for example, choose what type of merge option I want, hit OK. Let's say this is not something I want to merge in. I can undo that merge now. So as you can see, previous versions, it would disable that undo area. If I choose to, I can redo that locked area as well. So now we'll go into the locked areas. So as you can see, this is a locked item. If I choose to, I can copy and paste that locked item. So I can copy and paste that from file to file. In this case, just to show you, we'll paste this into the same file. I can also use a save part as within the locked area. Highlight them, and you can see how it's using the save part as. I can choose to save those files out as well. So that would allow me to merge those files into a different area. So next, we're going to go on some of the new plot view features. We now have the ability to create a broken view on a longer part to fit into a mask. We also can use a cropped view to also fit something into a mask. Within the outbreak section view, we now have the ability to create a circular section, whereas in previous versions it was just rectangle and polyline. So here's just a quick video. So I have this long part. I need to break that view to be able to fit it into my mask. Within the General tab, I now have the ability to select Break. Choose to break it in a horizontal or vertical break, but just by flipping those lines. I can add multiple point breaks here. and I can create an individual view. When I create multiples, I can delete those out, choose the length and width, or choose the distances I want to break that view. The nice thing when we break these views apart is it's going to still retain that full dimension. It's just going to add a breaking point into that dimension. So if I choose, let's say, and I create a dimension from one area to another, as long as it's in that breaking area, you'll see that little breaking point and it will still measure it out to the entire length of the part. Next, we have our cropping view. So if let's say our isometric view is outside of the masked area, we can then create the cropped area. We can choose to crop it from the top, right, left, bottom, and so on. So if I choose to crop that out, I can crop it out to resize it, and I can see that area that's cropped out. So I'll confirm that, and see how we crop that view into our mask. And lastly, we have the outbreak view with circular sections. So if I go to outbreak, I now have the ability to create a circular section. Previous, I just had rectangle and polyline. So I select this. I choose the depth value for that certain section area. And then I can apply that. So I choose the view I want to apply it to. Pick a point. And it's going to apply that section view. So as you can see, it cuts based off a circular section now. So from here, we're going to go into some of the bigger things that came out with the 2019-2020 versions. So we've added a lot more commands within the reverse area, which we're going to go over. So basically with reverse, it is compatible with any point cloud data that from an existing scanner, so you can use any point cloud data. You can directly scan into Visi using a hexagon product, such as a roamer arm. And the steps to convert, you would import the scan data into Visi. You would convert that data and clean a mesh. You manipulate the mesh to better reflect the part. You convert that mesh into surfacing, and thus converting into solids. So from here, we'll go into point cloud data. So Visi supports Leica laser tracker and roamer arm for direct scanning, so you can directly scan into the product. In 2019 R1, it also supports using these arms to pick up inspection points. And with the settings introduced in previous versions, we have the ability to import a larger cloud data. So basically in previous versions, they changed the ability to create a point from a cross into dots. So the dots make it easier and faster to scan. And the supported translators for your point cloud data would include your STL models, and ASC, NSD, ISO, RAW, and RMR. So we're going to start out and we're going to go through the steps of being able to create our mesh from point cloud data. So some of these commands were introduced in 2018 R2 and then also continued upon in 2019 R1 and also in 2020. So we have 4 commands to be able to create a mesh, but now we have a one-click mesh command, and these commands include the point to mesh, fill gaps, mesh refining, and mesh smoothing. So now they've been all rolled into one command, such as one-click mesh. So we're going to show those individual commands first, and then we'll show the one-click mesh after to show the differences. So still, you may want to use all 4 of the commands separately if you're working on a part and you want to refine it a little bit better. So we start out with our point cloud data, and we're going to use point to mesh. So we select our mesh area. We choose the average distance between points. We choose our different settings that we want to be able to create this mesh off of. And then once we confirm, it's going to build a mesh between all of our points. So you can see how it creates that mesh data. It's not exactly smooth, so that's where we start refining this mesh. And this is also based on how you scan the point cloud data, how all that data got scanned into the software. So from here, we go into reverse, and we start refining that mesh. So we would we'd pick the mesh, we'd start refining it, We choose the deviation error, how much deviation do we have, what's the maximum number of triangles, and so on. So from here we start cleaning it up, and then we would start creating a smoothened mesh. So it basically starts removing some of the extra triangles that shouldn't have been there. We go to reverse, and we select the mesh smoothing command. So I pick that mesh. I choose how many smooth cycles is it going to go through from 0 to 20. And then basically what it's going to do is it's going to scan through that part 10 times. So it's going to start trying to smoothen that mesh out. You can see how it starts removing some of those bumpier areas. From this, we would start creating that into surfacing. Now, this is with the one-click mesh command. You'll see all those combined commands we just used in the previous example. So you can see how this is all still, once again, points. From here, we just go to reverse, and then one-click mesh. So with the one-click mesh command, we select our point set. And then we have our point filtering, our mesh management, our refining mesh, our smoothing mesh, all rolled into one command. So basically I just hit apply, and that's going to create that mesh the same exact way we did in the previous steps. Again, there may be some scenarios you would want to use the individual commands, but in other scenarios you can use that one-click mesh. So within the mesh area, we now have some ability to start modifying and manipulating that mesh. So in 2019 R1, they introduced many new commands and enhancements for modifying the mesh. And the steps are mainly used to define the mesh rads, flats, planar holes, and hole sizes. So this step is to improve the results of the mesh, basically for creating your surfacing. And the commands include adapt mesh to circle, plane, cylinder, mesh cleanup, draft analysis on mesh, curvature on mesh, draw edges on mesh, smooth curve, and align. So we'll just go over some of those commands here real quick. You can see how when we scan that part, this whole feature shows up as it looks like it's kind of dipping in. So within our refining mesh commands, we have the ability to fix that. So we can adapt a mesh to a circle. Basically, we pick we pick our mesh, we pick the circle, and we pick a certain area where we want that mesh to be adapted to. So once I have everything the way I want it set, I confirm it, and it's going to start basically adapting that mesh to that circle. So you can see how that's now flattened, so it's not scanning into the part now, it's all flat area. I also have these little gap areas that, let's say when I was scanning, I may have missed these certain areas. I can go into the reverse area, and I can go to fill gaps. So within fill gaps, I pick my mesh. I pick the areas I want to fill in. So I select the gapped areas. And I can choose to fill those in. I just pick one in this example. You can see how it creates a mesh in between that gapped area. Since I have that ready, I'm going to go and confirm. And those are just some of the examples. We have some more towards the end as well. So we're going to start going into surface creation now within our reverse area. So we have two main processes for creating surfacing. We can create surfacing by a grid or create surfacing by color. In previous versions, it consisted of updates for surfacing, and some of those commands included grid on mesh, project mesh, mesh to surface, or the one-click surface. So in this example here, we're going to start creating our surface data. So under the reverse dropdown, we're going to create a grid on the mesh. So basically that grid is going to be used for creating our surfacing off of. So basically we choose our horizontal, our vertical pitches, the angles of those as well. So basically what this is going to do is it's going to project this grid along the mesh, and then we imprint it later. So as you can see, we change the angles. It's going to change the way it's going to create on the mesh, and so on. So once I have that area created, I can confirm it. And this isn't actually projected onto the mesh, it just creates it on the work plane of the mesh or the scan area. So from here, I'm going to project that onto the mesh. So I pick the mesh first. Then I choose what elements I want projected onto that mesh. Just like with the project elements, I can project that or imprint it. You can see once it's complete, it'll imprint that area onto the mesh. I'm going to use my visibilities to hide certain areas. I just want to bring out the mesh. And you can see when we flip this to wireframe, it imprints that area onto the mesh. And that can be used for creating our surfacing. So from here, I use the reverse, and I'm going to create mesh to surface. I'm going to use this command now. So basically I pick my mesh, and I pick the area or the entire part, if I choose to create into a surface. So I've got that meshed area. I pick a certain group or a certain area. In this case, we're just picking a certain area of it where it's going to create everything in my windowed area into a surface. Choose a surface tolerance, choose a boundary tolerance, and so on. So it's created 125 surfaces from 130 mesh faces. So you can see when I hide my mesh now, I can just see the surface area, and when I shade it, you can see that scanned part created as surfacing. So as you can see, we now have our surface area. If I wanted to join all those surfaces together, all I have to do is just simply unite those together. So if I go to unite, pick my surfaces, I make it all one surface. So within reverse, we have CPO scanning. We have updated RDS protocols to version 5. You have adjustable zoom levels, improved pan management, and you have live scanning for the XY directions. We have additional leapfrog methods for being able to scan larger parts, so you can stop your scanner and you can scan larger parts. And you have the ability to set a clipping plane. So if your part's sitting on a table, you can set that table as a clipping plane. So when you're scanning, it won't scan anything below that table. Next, we'll go into point probing. You can check the positioning for real-time digital readout. You have T-probing for Leica laser tracking support. You can create probe reference points for definition. And then you could choose for the point filtering, clipping plane filters. And now we'll go into some of the additional commands for the mesh area, like adapt profile to mesh. You can extract faces from a mesh, and you can create curvature or draft analysis on a mesh. You can align a mesh, and you can compare a mesh. So you're comparing your mesh to your original part. So let's go over the adapt mesh to profile command first. So you can see how it may have not scanned that area perfectly. We create a slot profile to better represent that area. We can adapt that mesh to that profile. So we select our part first, and then we choose the profile. So from here, we're going to select that profile. And what it's going to do is it's going to adapt that mesh to that profile. So as you can see, it's scanning that certain area. From here, we are now going to compare our scanned part to our original part. So if we do a align, we pick the mesh. We pick the solid. So this could be a mesh, it could be a point set, it could be whatever. So I pick a face that I want to align to. And from here, I can compare what does it look like before and after. So I take my point cloud data, put it to my original part, and I can scan to see what is different between each part. So you can see the differences. Next, we can compare the mesh. So just like the analysis compare, we have our point set, we have our mesh, or our solid part, our original part, and we can use the compare function. So we're going to choose our point set first. Then we can choose our solid surface or mesh. And basically what this is going to do is it's going to color code any differences between the mesh model and the point set. So you can see how you can adjust the range. When I hit preview, it's going to color code it based off of that specific range. So you can see your positive, your negative distances as well. So you can see how it color codes that in here. So you can see the differences, the comparable differences between each part. So we could choose to imprint a distance on it. So this would be like dimensioning. So you choose your different points where you want to dimension off of. And what that's going to do is it's going to add 3D annotation for all those distances. So you can see the distance based off of whatever specific parts we selected. So anything between this range and this range would be this color and so on. So you can see those distances now apply to the part. So now we're going to go into the mold for conformal cooling. So you can create conformal cooling based on sketched CAD functions inside of Visi. So you can create predefined shapes, or you can use a custom shape, and these are editable after subtraction. So we'll go over this real quick. So under mold, we now have the ability to create a conformal cooling. So I select my wireframe area. It's going to create different channels and different sections. So each section is individualized, so you can change whatever you want with it. So I could change the radius for these circular sections. It's going to default everything to circular. So if we go into the next area, choose to create that into a squared section. And from here, we choose how many sides we want, or what's the side size. Next, we can choose a rectangle. And within the rectangle, we can choose what's the blend, what's the length, what's the width, and so on. And what's the angle of it as well. So if I change my blend size between, see how it changes that. And then we have a rounded rectangle where I pick my part. You can see how it's rounded. Choose the length and the width, and it's going to base that rounded area off of that. And then lastly, we could use a user-defined shape. So you define your own shape. So when we have our shape, we select, let's say, a slot profile, choose our start and our end angle, or choose our center point of it, and it will create that part based off of that sectional angle. Once complete, I confirm it. I can use the subtract element cavities off of it to create our pockets. And then if I need to after this, I can still select those areas, and I can still redo my conformal cooling even after subtraction. So under mold, we go to conformal cooling. We just pick a face off of this area, and it will find the other faces, the other sections as well. So I can re-edit these after the fact. Now once I re-edit them, I just have to subtract them out again, but it allows me to edit them after subtraction. So if I need to change the radiuses again, I can do that. Next, I already have a predefined area for my conformal cooling. All I do is I can use conformal cooling, and then I can subtract that element cavities out of this area as well. So I pick my area. It's going to create a channel for me. I confirm that. And then I can use these subtract element cavities afterwards. I can pick that area and hit OK. So from there, it's creating the pocketing areas from that. So next we have ejector pin labeling. We now have the ability to label our ejector pins, whether it's a 2D label or a 3D label. It creates a reference table for us, and you can automatically recognize standard ejector pins, so ejector pins inserted with standard elements, and you can also create user-defined ejector pins as well. So in this example, we're going to go to ejector pin labeling. I just draw a window. It's going to select all my standard element ejector pins. And then I can choose my own ejector pins. Now when we choose our own, we just have to pick the reference face for where it's going to create that label from. So you can see how it pulls that up in a list. Now when we choose our own, the diameters and stuff, they're not already defined because they weren't inserted in with standard elements. So from here, I can add and remove ejector pins as I choose to. So if I want to add in more user-defined ejector pins or standard element-defined ejector pins, I can do that. All I'd have to do again is I would pick the faces. And then from here, I can go into how am I going to label it. So I can choose only numbers, letters and numbers, choose what do I want to label it as, what's my starting number, and what is my shifting value, what's the text, and so on. So when I go into here, I could choose to label these. So once they're labeled, I would see those labels inserted in. Now in some cases, like this E10, that label is not in the exact area I want it to be, I can manually edit it afterwards. So right now the label is 1 inch in the Y, or it's in the Y, so I just change it to the X. And then I choose that shift value. I can make it bigger, smaller. You can see how it shifts that value. So from here, I could choose to plot a table onto my area, and I can plot a table with all my ejector pin labels. And what's nice as well is with the ejector pin labeling, if I go into Assembly Manager, it's going to create a label column for me. And anything that's been defined with ejector pin labeling, it's going to automatically put that label in there. So E11, for example. And this is live updating whenever I make a change to my ejector pin labels. So if I select another ejector pin, you can see how it's adding that label column to Assembly Manager for my BOM process. What we can do with the ejector pin labeling as well is we can go in and we can edit a ejector pin if it was inserted with standard elements, and it'll update that ejector pin in the ejector pin labeling column. So as you can see, and from here I can also change the positioning. So what's nice with the ejector pin labeling is our profile or our engraved area is automatically aligned, so when we do a translation, it follows. And if I go back into my ejector pin labeling, I go to select my ejector pin. What's nice with this as well is if I do a, let's say, change my string number or string letter from F, and I do a 3D, I can choose what depth I want. It's going to 3D engrave that. It's going to automatically update my ejector pin labeling and automatically update my Assembly Manager. So now we have an engraved 3D heart inside of our area. So it's automatically engraved that. So we go into Assembly Manager. I pick one of my ejector pins. You can see how it automatically updated that label. So next we're going to go into some of the tool design areas. So we've had a lot of graphical and speed improvements within this area. So improved highlighting for plates and standard elements. We now have added some riser package for highlighting to not show inserted areas. We could delete user templates as well through this column. And within the Museburger area or any standard elements in general, it adds the CAM attributes. So for example, you have some drill holes, it'll automatically recognize those for machining later. So we'll just go into this example here. So we go into mold and then tool design. Just loading that in. We choose our template. We choose our template size. And inside of here, go to my riser packages. And see how it's pre-labeling everything in there. Change the sizes. Everything updates based off of that reference size off the database. And once I have that confirmed, I can go into standard elements. I can start inserting my components. So you can see that there is a speed improvement when it comes to inserting the standard elements here. From this, I can then go in, I can choose to insert that element or not insert that element. I can add inserted elements and so on. And if I choose to, if there's a template set, I can choose to delete that template within the interface now. From here, I'm just going to enable just this plate. And when I go into Surface Analyzer, I'm just going to check that face and I'll show you that there is a predefined hole there. So for example, when we go to machine this, if we use feature rec, it'll scan that as a drill hole. So it shows the drill diameter and the drill depth. So continuing on, there's a few additional templates that have been added for the Museburger area. We have the ability to draw a center of gravity on our part. And of course, as mentioned before, graphical and speed improvements. So I'll just show some of those Museburger templates real quick. So if we go into our template dropdown, you can see those different templates that it is added. So you select the layout and see how there's certain templates added into here. If I go into the dynamic section dialog, you can see how we have different standard elements inserted. You can see everything that's already predefined. We go into a different template, you'll see a different template here in reference as well. So each template can be designed to do whatever you need it to do. So we have this next one here. Change the sizes. And then we can also open the tool as well. We can rotate the tool from the ejection sides. And we can imprint a center of gravity point. So we can draw a center of gravity point on our mold. So what that's going to do when we confirm is that you'll see a blue sphere in the center of gravity point. So there's our center of gravity point. If we queried that point, that's going to define it as the center of gravity. It puts it into its own layer as well. You can see where it's at based on the work plane reference as well. So now we're going to go into standard elements. So this is something that we've been working on internally here with the progressive component libraries. So we have phase 1 and phase 2 complete available on the FTP site for the progressive components. So by the end of the fall, we're looking into having the entire progressive component library into the software. So basically from here, we're going to be requesting from you, the clients, to contact suppliers. So if there's components that you use from different suppliers that may not be available in Visi, contact your supplier to have them contact us. So we're working with Progressive directly to add this component library into our software. We're also working with Self-Lube to add their components into our library as well. So if there's any component manufacturers that you order from that you use over and over, feel free, contact them, contact us as well to have that library added into the software. So next, we're going to go into the progress area. So we're going to go into Visi Blank and we're going to show some of the new constraints that are added within Visi Blank. The first one is called pressure pad. So this option allows you to select a face to create a predefined relative force. So we'll start out with our face constraint as well as our pressure pad constraint. So I've got two parts here. They're the same part, but we're going to show the difference between a face constraint and a pressure pad constraint. So I have that orange face there. That's going to be the face I'm going to select my constraint from. So we'll start out with our face constraint, picking that face. Choose our XY direction, wherever we want it to be constraint from. So when I create my blank model now, that's going to be the face it constraints from. Just to show and reference, I'm going to select my mapped edges. I'm going to map those edges off of that face. So when we look at this, when we're creating our blank, you'll see that that's perfectly aligned to that face. What pressure pad does is going to use that face as a relative force area, and it's not necessarily going to align it perfectly. So you can see the different settings there. Next, we're going to go into the blank again. We're going to select our other part, except this time, with our constraint, we're going to select pressure pad. From here, we're going to select the pressure pad area. We have a drop down for pressure pad options. With that, we're still going to pick the same face as well, but this time we choose how much force and what the pressure pad is going to be based off of. We can use the scroll bar to adjust that. We can type in our own values as well for whatever we need it to be. So we type in our own values. You can see how it's going to adjust the total force automatically. And once we have everything created, we generate our blank. Just like with the last one, I'm going to go ahead and map the edges of that face so you can compare the differences between a face constraint and a pressure pad constraint. So as you can see, when we map our edges, if we flip this to a wireframe view, you'll see it's not exactly perfectly aligned to that face. It's using that face as a relative pressure pad forced area. So you can see how it's not perfectly aligned, whereas the other one is. So if I go into the display results, I can compare the different settings or the different results based on pressure pad and the face constraints as well. So when I scan my parts, you can see the total force based on the face constraint over the pressure pad. So you can get more improved results when it comes to previewing what is it going to do when it blanks. So you can see the total stress and so on. You can see the specific face to area in comparison with pressure pad force versus the face constraint. So you can see how those numbers change based on the different parts. So next we're going to go over the blank holder force. So within blank holder force, we can constrain to simulate the efforts of a uniform distributed blank holder force. So just like with our last example, we're going to go into Visi Blank. We're going to create one without the blank holder force and with the blank holder force. So to basically enable blank holder force under the tipping or the blank work plane, we want to draw. So from here, this is going to be without holder force. So I'm going to go ahead and apply that. And that's going to create our blank. As you can see here. And then with our other one, we're going to apply that holder force next. So if we go to progress blank Visi blank, select our part. I'm going to go to draw. And then I'm going to select holder force. And just like with the pressure pad, I have the ability to adjust how much force is going to be applied, what's the friction, or I can use the scroll bar and I can adjust from that. So when I go to blanket, it's going to now apply that holder force when it comes to my blank preview. So you can see how it's actually applying a holder force. I can adjust that holder force, re-blank this part out. So you'll see the difference based on what I'm adjusting. So how much holder force am I going to apply to my part? You can see the before and the after. So from here, I can compare the two blanks here, side by side, and see the difference between having holder force applied versus not. So continuing on with progress, we now have added a new part unfolding module for unfolding solids, so there's no need to extract faces. The associativity between these solid parts is also applied as well, and we have enhanced part recognition. So we'll start with this example here. So if we go to progress, we now have the part unfolding module. So we select part unfolding, choose the face or the faces, and you can see how it applies just like with part study, the linear flanges, the ribs, and so on. So we can create an unfold. So this is going to create our blank preview example. We adjust where that example is going to be created from. And then from here, we can start creating our steps to unfold this part, and thus start creating our unfolding steps to create a strip from. So we go into part unfolding, and we're going to start unfolding the part by steps. So I pick my face or the faces that are applied in this step, and we could choose to unfold that. So what's my start angle? My new angle is going to be, let's say, 45. When I hit preview, it's going to create a step automatically for me for my original part. It's going to start unfolding that. Notice how this is all unfolding from the solid, so we are not extracting any faces. It's automatically doing this. We still have the ability to extract a face if we have to as well, but going on to this next step, we're going to basically start unfolding it again. We can choose from here to add a new step, so add a new stage for my unfold, and you can see how it's going to allow me to dynamically translate it as well. So we'll continue on with this command. We'll pick the face or the faces we want to start continuing our unfold from. Unfold that one. And then we'll choose our next face to unfold from, or faces. And then we created our step to get to our blank. Now notice, with our blank, the nice thing is, any ribs that were associated, those are automatically flattened. So it automatically removes any hole association for any of those ribs that were created from the unfold areas. So another nice thing in this part unfolding is if I make a manipulation or I take something out of my part, add something in, I can automatically update the rest of the strips parts. So if I add a hole into here, I will add that hole, subtract it out. The nice thing is, all I have to do is just re-update my strip area or update my part unfolding. So I go to part unfolding, reselect the face, and then I can rebuild those parts. So I select rebuild links, and what that's going to do is it's going to update all of the other stages and add that hole into all those other steps. So you can see how it adds that hole into each individual step. From here, I can also extend this length. So I'm just using basic modeling commands to extend the length. So I'll use, let's say, edit faces. I pick my blended areas, and I could choose to extend that length out. Once again, when applying that to the rest of my parts, it's going to automatically apply that new length to that area. So I just go into part unfold, pick the face again, hit preview with rebuild links turned on or confirm, and you can see how it changed that length for all of those parts. You can see how everything updates within it. If I go in and add an additional solid area, as long as it's the same height as the part, when I go to create with Unite, and I reapply my part unfold, basically re-updating it, you'll see that it adds that area as well. So I pick the face, and when I go to rebuild links, it's going to automatically apply that cuboid I just created into my part. So it adds that to each and every step. Continuing on with progress, with wire point by plates, we now have a new user definable rule area. So there's two possible groups for this area, features and holes. And what this does is, by default, it would normally for circular features apply that wire point to the center of that hole. By request by many, we've added in the ability to create our own applied point, user defined. So under progress, we go to wire point by plate. And you can see this is the default here. So you can see how they're all basing off of the center areas. We go to settings and we have a new tab called rules. So within rules, we can enable these rules. And based on the diameter of each of the circles, in reference, that's where it's going to create the offset from for each range. So when I reset my selection, applying those rules to my table, you can see how it's automatically going to predefine our wire point hole off of those certain areas. So whatever is applied, that's what's going to automatically put in. So you don't have to manually change these wire point holes afterwards. I still can if I need to as well, though. So we go back to settings, we can go to rules, and we can make some adjustments as well here. So after all of our ranges, we could set an other offset, and we can predefine that as well. So that's going to apply our different areas for each whole feature. So now we'll go into the flow features. We have coolant flow rate suggestions. We can create cavity meshes for thermal analysis. We can display flow lines within our area. And we also have enhanced mesh technology. We have direct interface to Digimat from MSC. And here's just a quick example of this. So we'll start out by going to the wizard, creating our mesh to be able to create our flow from. So we choose our parameters. Within here, you can see how it's going to preview it, and you can see based on these parameters how we can manipulate that mesh to apply to our part. So we can automatically decide, we can create a mapped area, we can preview it, you can see how it's going to apply our certain areas. So we can auto decide, we can create curvature, preview it. You can see how it's going to change the way that mesh is going to be applied. And so you can see based on these settings we're manipulating our mesh to further better the part. So we just continue adjusting some of these settings in here. You can see how it's basically adjusting how is our mesh going to create. So in certain areas it's going to be refined a little bit smaller, in other areas it's not. So from here, when we go into our flow analysis, you can see how we have improved thickness based on that mesh that we've manipulated. So next we're going to show how you can display flow lines. And when we're going into our preview, we have the display flow line, so you can see where that flow is actually going to go to next based on our different parameters, our different settings. You can see how it's applying those flow lines to our part. Thanks for watching. Please like and subscribe for more videos. If you have any questions or like to see a live demo, please contact us at 248-922-9293 or by sales at tst-software.com.